Hello, welcome to part 2 of lesson 10-1. We're continuing on our introduction to our new unit, or the first lesson of our new unit. Last time we talked about sequences. This time we're going to talk about series. The first thing we have to learn is about summation notation. It is a convenient notation for the sum of the terms of a finite sequence. It's called summation notation or sigma notation because it involves the use of the uppercase Greek letter sigma, written as that right there. That's going to play a key part in terms of series. The definition of summation notation is that the sum of the first n terms of a sequence, represented by the following statement, where I is the index of summation, n is the upper limit, and 1 is the lower limit. Okay? Pay very, very close attention to the number that's on top of the sigma. That is the upper limit. We'll show you what that means in a moment, and the lower limit. Notice next to the sigma is A sub I. What A sub I is, that is your sequence term that you learned about in the last lesson, where you'd have some sort of expression. And so what a summation is going to be is that you're going to add. So for example, if I told you, back to our example from the last one of odd numbers, 1, 3, 5, and 7. Well, 1, 3, 5, and 7 are the first 4 terms, and if you had a sigma sign in front of that with the number 4 on top, then that would tell you to add the first 4 terms of a given sequence. So you'd have 1 plus 3 plus 5 plus 7, so you get an actual answer. So find each sum. So in this case, your upper bound, you have the summation of 3i, or sigma of 3i. So in this case, you're starting at, notice the upper bound tells you how far you're going. That's the number on top of the sigma sign. The number on the bottom tells you where you're starting. So we're starting at I equals 1. So we're finding the summation of 3i for the first 5 terms. So 3 times 1 plus 3 times 2 plus 3 times 3 plus 3 times 4 plus 3 times 5, which then gives you 45. Okay, you would add those up. That's what you're doing with the summation, is you find the number of terms it tells you to find, and then you add them. Okay, the next one was, the upper bound was 6. You started with k equals 3. That was the lower bound, so we started with the lower bound was 3, and so now we're going to plug in up through 6, not 6 terms, but we're going to plug in up through the number 6 in for k. So 1 plus 3 squared, plus 1 plus 4 squared, plus 1 plus 5 squared, plus 1 plus 6 squared, which gives us 90. So once again, notice, let me get out my laser pointer here. Life is more fun with the laser pointer. Notice on the top right here that this point right here, this is my upper bound right here. That tells you the highest number that you're going to plug in. The k tells you where you're starting at. So this is your initial and this is your final. This is what you're plugging it into, and so you're going to start with this number and you're going to say, all right, 3, so 1 plus 3 squared. Okay, the next number is 4. 1 plus 4 squared, and so on and so forth. And then, starting at the term 0, you're going to find the summation of, through the 8th term, of 1 divided by I factorial. Now, we talked about factorials in the last lesson. That's where you're going to multiply, starting with the number times every subsequent smaller number. So 1 over 0 factorial. That's your first term. Because we started with 0, now we're going to go up through 8. 1 plus 0 factorial. 1 plus 1 factorial. So on and so forth through 8. which gets us 1 plus 1 plus 1 half plus 1 sixth, 1 over 24, 1 over 120, 1 over 720, 1 over 5040, 1 over 40, 320. And you would add those all up and you would combine them. Your goal with anytime you have a summation notation given is to have a specific number on the outside of it. You're getting a number for this. Some properties of sums. These are some properties of sums. So in the event that I have the sum of some sort of constant, it's just the constant times the number, where C is a constant. Over on the right, the second one. Let's say I have the sum of some sort of sequence or series, and it is a constant number times your sequence. Then that is the same thing as if you were to pull the constant out and just take care of this part right here and then multiply it by C. So think of it as if I have something that's on the inside being multiplied by my terms of my sequence in here, my sequence or series on the inside, then I can just basically think of it as undistributing it out. If I have the sum of two sequences, then it is the same thing as the sum of the first one and the sum of the second one. I could treat them separately or I could combine them, and the same thing with differences as well. Now, many applications involve the sum of terms of a finite or infinite sequence. Such a sum is called a series. So, consider the series A1, A sub 2, A sub 3, so on and so forth. The first n terms is called a finite series, or the nth partial sum, as denoted by this. So finding the sum of all the terms of the sequence would be a finite series where you start at 1 and go through the nth term. Technically, what we just did were finite series, where we were given some sort of expression and told to start at a certain number and go up through another term and plug those in and then sum them. That's called a series. Now, the sum of all the terms of an infinite sequence is called the infinite series. So remember, the series is basically the summation of a sequence. The sequence is some sort of term you're given where you're given the first term will give you some answer, such as the first odd number is 1, the second odd number is 3, the fifth odd number is 5, so on and so forth. Whereas in this case, notice the difference between this one and this one, between the infinite and the finite series, is that on the top the upper bound is n, whereas on the infinite series the upper bound is infinity. Okay? So for the series, find the third partial sum and the sum. So we've got the series of basically the summation of 3 over 10 to the I power. Our upper bound is infinite, and our initial, we're starting at 1. Now when we find the third partial sum, that means for the first one, we're going up basically through the third one. So even though it has the infinite series, what that means with the infinite series on top is that it could potentially go infinitely. Much like you often think the sound of my voice does, that you think in class that I can just keep talking and talking and it'll never stop. It can keep on going forever and ever. In this case, though, when they define it as the third partial sum, they're saying, all right, find me from your initial point, go up through the third term. So 3 over 10 to the first, plus 3 over 10 to the second, plus 3 over 10 to the third, which gives you 0.3 plus 0.03 plus 0.003, which gives you 0.333. That is your answer. Now, the infinite series, the sum of the whole series, is continuing on repeatedly, and in this case ends up forming the fraction 1/3. Keep in mind that in the case of this series, the farther you go, the less drastic the change. 3 over 10 to the 5th power was 0.00003. That is a very small change. So in the case of this series, as you go in, or in terms of this sequence, as you go further and further along the sequence, in this case, it's getting infinitely smaller. And so at that point, you can make a general summation to 0.333 repeating, and you know from basic fractions that that is 1/3. Okay? So 2 types of problems here. You're given the summation of a sequence. You're told to find the third partial sum, which means you're going to treat it as if the upper bound is 3. Start with your initial, go through your upper, and then the second thing that you're given is infinite.